Good morning everyone. Today we're going to talk about coordinate geometry in the XY plane. This is chapter 5 in your book found on page 73. Particularly we'll talk about the general form of the equation of the line, the gradient of the line, and also the standard form of the equation of the line. So our intended learning outcome for the following is understand the link between the equation of the line and its gradient and intercept. Calculate the gradient of a line joining a pair of points and rewrite equation of the line from standard form to general form and vice versa. Now let us talk about first the equation of a straight line. Any straight line is an equation of the form y equals mx plus c, where m and c are constant. So this will be your m and this is our c. This is known as the standard form of the equation of the line. So this form, y equals mx plus c, is the standard form of the equation of the line. The value of m, this m here, is known as the gradient and is the measure of steepness or slope of the line. The value of c gives the y coordinate of the point where the line cuts the x-axis. Now this is also known as your y-intercept. So in particular, the value of c, since this cuts the x-axis, this is the y-intercept, the coordinate at this point will be 0 and c. Okay, this will be 0 and c. C is this number and x is equal to 0. This will be your x. The general form, on the other hand, is given by ax plus by plus c equals 0, where a, b, and c are all integers. Now remember that a, b, and c are all integers. There must be whole numbers, positive or negative. It could be 0, no problem. Okay, let's take a look at some examples. For example 1, let us write down the gradient and the intercept on the y-axis of these lines. First, y equals negative 3x plus 2 and letter b is 4x minus 2y plus 5 equals 0. Let's take a look at the solution for example number 1. So if you're given y equals negative 3x plus 2, from the general form y equals mx plus c, here we can see that m is equal to negative 3 and c is equal to positive 2. Okay, so these are these values here. So therefore our gradient m is just negative 3 and the intercept on the x-axis will be 0c, which is the point 02. Okay. Now letter b. The equation is given in standard form, 4x minus 2y plus 5 equal to 0. So the first thing that we're going to do here is to rewrite this one into the general form, y equals mx plus c, this form. Okay? Because from here we can determine directly what is your m and what is your c. So to do that, from 4x plus 5 equals 2y, so what I did is I just put 2y to the other side, so negative 2y becomes positive 2y. Or if we will flip the equation, we get 2y equals 4x plus 5. Now we want to make sure that the numerical coefficient of y, which is at this point is 2, is equal to 1. So what we do is we divide both sides by 2. So now we have y equals 4x plus 5 divided by 2. And finally we get 4x divided by 2, we get 2x, 5 divided by 2. Okay, 5 divided by 2, we get 5 halves. So the equation of your line in standard form is 2x plus 5 halves. So from here, your gradient m equals 2. This, your m. And the intercept on the y-axis is 0, 5 halves. Okay, versus this is your c. Okay. Okay, so let's continue. Let us take a look at example number 2. Write these lines in the form ax plus by plus c equals 0. So here we want to write the standard form to general form. Now remember, in the general form, your a, b, and c must be integers. Okay, this must be integers. So let's take a look at the solution. So first, y equals 4x plus 3. Now the first thing we do here is we put everything to one side and the other side should be 0. So we can put y to this side. So we get 4x minus y plus 3 equals 0. And let us flip the equation. We get 4x minus y plus 3 equals 0. Now this is in general form, where your a is equal to 4, your b is negative 1, and your c is equal to 3. Very easy. Second example, second problem. This time we have y equals negative 1 half x plus 5. Now notice this one. The coefficient of x is a fraction. So to simplify the computation of this one, to simplify the transformation of this standard form to the general form, let us free this one first from fraction. So what we do is we multiply both sides by the denominator of the numerical coefficient of x, which at this particular example is 2. So we multiply 2 to y equals negative 1 half x plus 5. This gives us 2y equals, of course, 2 times negative 1 half is negative x. 2 times 5 is 10. Okay. Next, let us put this to the other side so that we get negative x becomes positive x plus 2y, positive 10 becomes negative 10. So the resulting general form of the equation is now x plus 2y minus 10 equals 0. So here you will get x equals 1, b equals 2, a equals 1, b equals 2, and c is equal to negative 10. Okay, let's continue. Let us take a look at example number 3 now. Example number 3 says a line is parallel to the line y equals 1 half x minus 5 and its intercept on the y-axis is the point 0, 1. You're asked to write down the equation of the line now. The word here, the keyword here is parallel. Now when we say that lines are parallel, their slopes are equal. Okay, so when two lines are parallel, their gradients are equal. Remember this one, this is very important. Every time you say the word parallel, two lines are parallel, automatically the gradients are equal. So from the given equation, y equals 1 half x minus 5, we get the gradient equal to 1 half from here. It's very clear. That's the numerical coefficient of x. So m is equal to 1 half. Now we are also given the intercept on which the line crosses the y-axis, the second line, which is 0, 1. This gives us the value of c equal to 1 from here. Okay, c is equal to 1. Therefore, the equation of the line, the other line, which is parallel to the line y equals 1 half x minus 5, is y equals 1 half x plus 1. Now this is your c, this is your m. So we say that y equals 1 half x minus 5 is parallel to the line y equals 1 half x plus 1. Notice there is gradients. They have the same gradients. So they are parallel lines. Okay? Example number 4. Now this time, a line is parallel to the line given by the equation 6x plus 3y minus 2 equals 0, and it passes through the point 0, 3. Okay. Remember the given is in general form. So to get the gradient of the first line, we should rewrite this one into standard form first. We are also given the intercept of the second line, which is 0, 3. Let us work out now the equation of the line. Okay, so the first thing we do is again we rewrite the given into the standard form. So 6x plus 3y minus 2 equals 0. We put 6x and negative 2 to the other side. That will give us 3y equals negative 6x plus 2. Next, we make the numerical coefficient of y, this y. We make this equal to 1. So what we do is we divide both sides by 3. So we get y equals 3 divided by 3, that is 1. Negative 6 divided by 3 is negative 2, and we have 2/3. Okay, so this is now your standard form. So from this standard form, we see that m equals -2 from there, okay? And so therefore, the equation of the second line is y equals -2x, this m, since they are parallel, okay, they are parallel, their slopes are equal, at plus 3, this 3 is taken from here, this is the intercept of the second line. So the equation is y equals -2x plus 3. Okay, I think that's very clear. So if you take a look at page 76 of your workbook, there's exercise 5a there. So you can try all those exercises if you want, and you can check your answers at the back of the lecture notes. Okay, just located there. It's at the back. The answers of these exercises. Excuse me. Now let's continue. So far we have been talking about the equation of the line in standard form and in general form. Now, to get the equation of the line, we talk about the gradient of a line. The gradient of a line can be determined also if you have 2 points x1 and y1. Okay, so let us define this formally. The gradient m of the line joining the point with coordinates x1, y1 to the point with coordinates x2, y2 is given by this formula. So this is m is equal to the difference of the y coordinates divided by the difference of the x coordinates. Now in other books you will see that this is defined as the rise over the run, or the change in y over the change in x. Delta y over delta x. So remember this equation, this is very important. To determine the gradient of a line given any 2 points, we can get it by simply using this formula. The difference of y divided by the difference of all x coordinates. Let's take a look at example 5. Let us work out the gradient of the line joining the points 2, 3 and 5, 7. So for 2, 3, we have x1 is equal to 2, this will be your x1, and your y1 is equal to 3. Now for the second point, 5, 7, x2 is 5 and y2 is 7. So the gradient is, according to the formula, m is equal to y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So what is y sub 2? Y sub 2 is 7 here. Minus y sub 1 is here, that's 7 minus 3. The denominator on the other hand, x sub 2, which is 5 here, and -2, which is our x sub 1, minus 2. So 7 minus 3 is 4, 5 minus 2 is 3. So this is now your gradient. So the gradient now is 4 over 3. So again, it's the difference of your y coordinates divided by the difference of your x coordinates. Now, in this particular case, it doesn't matter which is your x1 and which is your x2. You can also use 5, 7 as your first point and 2, 3 as your second point. The answer will be the same as long as you're consistent. If you choose 5, 7 as 5 as x1, therefore you should also choose 7 as your y1 and vice versa. So if you choose 2 to be your x sub 2, then you should also choose 3 as your y sub 2. So it will give you the same answer. You can try it at home and you will get the same result. Let's continue. Now example 6. For example 6, same problems. Let us work out the gradient of the line joining this pair of points. Letter A, we have -2, 7 and 4, 5. Letter B, 2D minus 5D and 6D minus 3D. Let us look at solution of example 6a first. So if we are given -2, 7 and 4, 5, so this will be our x1, this will be our y1, this will be our x2, this will be our y2. So the formula says m is equal to y2 minus y1 over x2 minus x1. Just plug in the values. So what is your y2? Y sub 2 is 5 minus y sub 1, which is 7, divided by x sub 2, which is 4, minus x sub 1, which is negative 2. So this gives us 5 minus 7 is negative 2, 4 minus negative 2 is 6. Reduce to lowest term, we get m equals negative 1/3. So negative 1/3 is the gradient of the line joining the points negative 2, 7 and 4, 5. Okay. Now you can also look at the graph of this one. Because when you look at the graph of this equation, say for example, I just draw it roughly here. So this is negative 2, this is, okay, 7 is somewhere here. So this will be this point, and then 4, 5 is, okay, I made a mistake here, 4, 5. So it looks like, the line will look like this. It's inclined to the left. Now this is due to the fact that your gradient is negative. When your gradient is negative, your line tends to incline to the left. When your gradient is positive, your line inclines to the right. You can try other problems and try to plot the points. You will see that when m is positive, it is inclined to the right, it's going up. And when m is negative, it's going down. Okay, sample 6, letter B. This time we are given 2d minus 5d and 6d, 3d as our second point. So again, let us, from the formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, you get your y sub 2, which is 3d, minus y sub 1, which is negative 5d. What happened? Negative 5d. Then x sub 2 is 6d minus x sub 1, which is 2d. Okay, so we now have 6d minus negative 5d over 6d minus 2d. So 3d minus negative 5d gives us 8d. 6d minus 2d gives us 4d. Now you can cancel out d. 8 divided by 4 is 2. So now, for this particular line, your gradient is equal to 2. So the gradient is positive. It is expected that the line inclines to the right. This line is going up. You can try it at home. Try to plot the points of this line. Okay. This will be our last example. Suppose that we have 2 points, 2, negative 5 and 4a. This is joined by a line which with gradient equal to negative 1. Work out the value of a. So the line joining 2, negative 5 to 4a has gradient negative 1. And let us find the value of a. So this a here. So what is this? Now, we are already given the value of m. The gradient is negative 1. So from our formula, m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, same formula. Now, but let me choose a as my y sub 2, 4 as my x sub 2, negative 5 as my y sub 1, and 2 as my x sub 1. So if we substitute value, now we know that m is equal to negative 1 from here. M is negative 1. Y sub 2 is a minus y sub 1 is negative 5. X sub 2 is 4 and x sub 1 is 2. Okay. So we have 4 minus 2 is 2. Negative times negative, that gives us positive 5. So a plus 5 over 2 is equal to negative 1. And what we do, we free this equation from fraction, we multiply both sides by the denominator cube. So what the resulting equation is negative 2 equal to a plus 5, or that gives us a equals minus 2. Put this to this side before you flip the equation. It gives you negative 2 minus 5, which is negative 7. Okay. So the value of a, which is your y sub 2, is negative 7. Now if you plug this point here, negative 7, and you solve for the gradient, you should get this value -1. Okay, so now your points will be 2, -5, and 4, -7. Okay, so from these 2 points, try to check if the value of the gradient is negative. The value is -1. It should be -1. Okay. So if you look at page 78 of your workbook, there is exercise 5B. Okay, this is on solving the gradient of a straight line. Try these exercises, and again, check your answers at the back of the workbook. The answers are there. So next time, my next video will be about finding the equations of a straight line. So we will talk about the equation of a straight line if you are given a gradient and a point. So that is one formula, and we have another formula where we are given 2 points, x sub 1, y sub 1, and x sub 2, y sub 2. How should we get the equation of the line if you have those in a given? Okay, so should you have any questions, please don't hesitate to send comments in the Google Classroom, and yeah, I'll get back to you as soon as I can. Okay, thank you.